Just a little bit about IDA Ireland, the role that we play in the Irish economy. First of all, we're responsible for attracting foreign direct investment to Ireland, and that plays a very, very strong role in the Irish economy. It's about 2.5 times more important in the Irish economy than it would be in the UK, for example.
So SOCs, to my mind, basically commoditise complexity. That's what this whole industry is about. We spend years getting this right, but then we can actually get it in with the economies of scale that the industry works on. We then commoditise it. And we've done that now with processing, with video, with graphics, with cameras. And these are the things that consumers understand, that end users understand.
Is that we're working hard to bring in technology, as I mentioned, we're making the next generation available in time to our customers. We invest heavily to provide capacity.
In fact, once you have the intelligence of this SoC chips, putting the metal around it wasn't that big a deal. We could make those devices ourselves. And moreover, as I mentioned earlier, we're moving from mobile to handheld now to wearables.
On the manufacturing front, Crocus is building its own production facility in Russia in partnership with Rusnano, a very large Russian fund, and they will have the opportunity to come back on this joint venture. Last but not least, as you can imagine, Crocus Development, as a startup company, has been financed and therefore made possible by a group of international investors, US, Switzerland, France.
If you look in the last column of that table, or the last row of that table, that for different parts of the world, for instance in Southwest USA or Middle East or Chile, the break-even cost of a silicon module would have to be 41 cents in the Middle East to now be competitive with CPV.
Of either a mobile device on one side or a base station or MSC on the other side, the energy costs are much, much higher. When you look at that energy cost and amortize it over a very long period of time, you will realize that you're spending a lot of money in driving your electronics platform.
And that is why Europe needs to be on the map. European know-how, European technology, European companies. The label Airbus of chips is just a shortcut to signal this important goal for our connected continent, not just for manufacturing, but also design and technology in all areas.
What we wanted the strategy is bold. So for the first time you can see a communication from the Commission, a strategy of the Commission says we think that investment should be done here, here, here and here, and less than 10 places across Europe. First time we say, let's build on our strength in these fields. And we know that by building on our strength, on these hubs of excellence across Europe, we'll be serving the whole European economy across member states.
Time that we nearly cruise from I think a fairly dark kind of attitude about Europe, where Europe was very much trying to protect itself and what it already had, to a time that we're now talking about doubling the capacity. I think it's great to see that kind of ambition. And some of the details of the documents that have been published, that's for instance say that we're going to prioritise more than more and 450mm equivalent materials. I think are all very encouraging because they're all the right things, and we see those as the right things for the industry. So as European partners, which we very much regard ourselves as in Intel, we're delighted that the Commission is really stepping up and showing this kind of leadership.
And this is the burning platform behind our innovation at IMEC, and we see definitely life science and healthcare as one of the major thrusts in innovation in the coming decades. So we need to bend this curve. We need to do things, and we strongly believe, that introducing some of the paradigms we have in the semiconductor industry will help doing that, and we see our partners following the same trend.
It has to be there. We know we need to go down in geometries. We know that sub 20 nanometer and even sub 10 nanometer is what's being worked on at the moment. That means it's going to need 18-inch wafers, and the technology is going to be there to be able to get there. But I think that in Plessy's view, the front end of that, the interface between us as humans and all of that digital, is a whole pile of sensors.
So what I want to do now is basically walk through our latest outlook of the industry, how we see things shaping out. And I called the presentation Plus ça change. The more things change, the more they stay the same. And the answer to that question is yes, no, and maybe. So I've covered my bets. Some things will stay the same, some things will change, and some things are still open to issue there. So I just want to run through some of the things that we're talking about.
By the time we were 30, 40 years into the field of robotics, we had some fairly sophisticated systems like the ABB Flex Picker, which could literally pick thousands of parts per minute and operate in a way that no human being ever could imagine operating in.
Simulation is an interesting tool, actually, and one of the criticism towards the Human Brain Project is that people say, well, it's too early to do this, because you cannot simulate what you don't understand. We hear that all the time. We haven't understood the brain, so how can we simulate it? And I think this argument is fundamentally flawed.
There will be a very huge amount of data to be processed, and the traffic will be multiplied by a factor of 1,000. So if we have to keep data server below, as it is today, 20 megawatt, because it seems impossible to go higher of this value of 20 megawatt for data center, you need to have a power efficiency gain of 1,000.
So even without physics, this kind of interface is a great candidate for some future interactions. If you get hold of thin, transparent OLEDs, for example, these are from Samsung, you can actually develop, very interesting things with an extra dimension in dealing with content on the screen, and not necessarily with having to build a full-blown 3D display.